So a sequence is an ordered list of objects. You could have a sequence of people, sequence of food, a sequence of pages in a book, things like that. But typically, for our purposes, sequences will always be of numbers. So we're talking about sequences of numbers now. And so what is a sequence? A sequence is an ordered list. That's the important thing, that there's this structure. It's all about it being ordered. Okay, so what are some examples of sequences? Well, we start counting 1, 2, 3, 4, 5, 6. That's a sequence of numbers. Implicitly, when we do this, we assume that there's a pattern, so it can continue. So the next number is 7, the next number is 8. Obviously, you can construct a sequence however you want. So you can construct a sequence 1, 2, 3, 4, 5, 6, 18, just like random like that. But whenever people write these like dots, they assume that there's a well-established pattern that you can figure it out. So here are just 3 examples of sequences. Okay, so the notation when we're talking about like an abstract sequence, or just say take a sequence, but we want to write some definitions or some constructions that involve sequences, so we need a notation to denote that. We can't just write the words take a sequence. So the notation is as follows. We write a sequence using this notation here, so we put these brackets. The brackets means it's a set of objects, and the objects typically all have a common letter. So in this case, the common letter is A, and then there's a certain subscript, and the subscript is used to identify the place of whatever in the order. Okay, so this notation here, in brackets, so this thing here is the same as just saying this. There's an object A1, then an object A2, then an object A3, and an object A4. Okay, so the subscript is telling you what you're calling, what you're counting over. So this number here is the first object. That's what's over here. The second object is over here. The third object over here. So I'm calling like the objects all A, and then A sub 1 means the first object, A sub 2 means the second object, A sub 3 is the third object, and so on and so forth. And the fact that we're using the symbol A here, this A here is just a symbol, so we can use any symbol we want. So here's an example. In quotes, the sequence bracket Bn is the sequence. So now it's like there's the first object, the objects are now B's, so you have object B1, then you have object B2, then you have object B3, you have object B4, etc., etc., etc. So that's just some common notation. Okay, and so what is, so that's what sequences are. It's not a big deal. They're just ordered lists of numbers. So how can we describe sequences? You can just take a random number generator and just generate random sequences, but that's not usually what we're dealing with in the real world. So sequences can be constructed by a function. So for example, if you have some function, it means you input numbers and you spit out numbers, then you can construct a sequence where like the first object is the output of 1. So this means that like the first object is f of 1, the second object is f of 2, the third object is f of 3, etc., etc. And we often turn this around. Often we'll notice, we'll be given a sequence, and we try to construct a function or a formula for that sequence. So let's just do a few examples to see how this works. So here's an example of a sequence. The sequence AN is given by, as a set, let's say it is 3 to the n over n factorial. And sometimes you have to say where it starts from. So notice that in all of these cases, I sort of started counting at 1. So over here I said, first you have object 1, object 2, object 3, but you can actually start anywhere. So let's specify that. Let's say we'll start with n equals, so we say n bigger than or equal to 1, say. So then you see that the first object would be 3 to the 1 over 1 factorial is, of course, 3. The second object in this list would be 3 squared over 2 factorial. So that's 9 over 2. The third object, I'll put commas, the third object in this list would be 3 to the third power over 3 factorial. So that's 27 over 8, etc. So here, the function that's describing these things is given by, this looks kind of bad. So this is, I'm really bad with drawing these brackets. But so in this example, like you have this function f of x is 3 to the x over x factorial. Is defining the sequence itself. But there can be lots of other types of things. So there's one example. Here's another example. If we took something like, so sequence b sub n, let's say that's defined by 3 plus negative 1 to the n times 1. So this is telling us this is b1. So again, what determines the object, the thing in position n, is given by wherever n manifests itself on the right-hand side. So here we have, for example, b1 is equal to 3 plus negative 1 to the 1 times 1. That's 3 minus negative 1 to the 1 is just 1. So that's equal to 2. b2, on the other hand, would be 3 plus negative 1 squared. In fact, I don't even need to write that 1 there. I'll just ignore that. 3 plus negative 1 squared, and of course that's 3 plus 1. So that's equal to 4. And then b3 is equal to 3 plus negative 1 to the third power, but negative 1 to the third power is still minus 1, so that becomes 2 again. So you can see the pattern that this sequence will alternate outputs. This is 3 plus 1. So the sequence looks like, so the sequence is like 2, 4, 2, 4, 2, 4, on forever. Okay, and then there are other things you can do. For example, you can try to identify, well, whatever. So, just a remark is that sequences can start at any integer. Okay, so for example, if you if you have a sequence like b to the n is a sequence given by n squared, right? So the order matters, but you can say, well, you can extend these things in both directions indefinitely. So for example, you could say, we certainly have that like b1 is equal to 1, b2 is equal to 2 squared is 4, b3 is equal to 3 squared, which is 9, b4 is equal to 16, etc. But we can also go backwards. We also have that like b0 is 0. We have that b negative 1 is equal to positive 1. We have b negative 2 is equal to positive 4. B negative 3 is equal to positive 9. And so, you have to be careful where you start. So we can write the sequence as b minus 3, that comes before b minus 2, that becomes before b minus 1, that becomes before. All that matters is how they're ordered. And so this is the correct ordering here. So the sequence looks like 9, 4, 1, 0, 1, 4, 9, 27. And it extends forever in both directions, okay? But the order is still like that. And so it's important not only to keep track of the order itself, but also the location. So sometimes you want to keep track of the location. So this is like object in position 0, object in position 1, This is object in position -1, in position -2, in position -3. So sequences can start anywhere.